Hello and welcome to the IT/OT integration session with WinCC OA. So first of all, a little bit an overview, what you will hear today right now. So first I will give a little bit an introduction, an overview about what is MQTT and why is it getting so famous nowadays. Then we will dive into technologies, so compare a little bit SCADA, MQTT, but also Apache Kafka. And then we will jump to the payload, so different payload formats, which are a lot of times used together with MQTT. And then we will learn about the Unified Namespace, the UNS. And of course, last but not least, we will jump directly into action with WinCC OA and showing some demos. So, introduction overview. MQTT. So, it is really nothing new. It was already invented in the year 1999 by Andy Stanford Clark and Alan Nipper at IBM. And at those days, it was primarily made, or initially made for monitoring pipelines. And at those days, the network connectivity, network connections were not so reliable as it is now. And because of that, it can deal with unreliable networks, with high latencies, and also deal with low bandwidth. And it is also very lightweight. Yeah? The clients can be implemented in a very lightweight way, so it also fits on very small devices because of its small code footprint. And applications, yeah, I already said it, it started with oil and gas, but nowadays it is also going very heavily into the manufacturing and also into the area of Internet of Things. For example, connected cars. Yeah, you can connect or monitor a lot of cars, millions of cars, which are connected to one central broker in the cloud. From point to a central data hub. So here we see now the more or less the state or how it was done, or it is still done, of course, in that way that we see point-to-point connections. So that means systems are getting in touch to other systems and they requesting data from there directly. And that can lead, you see it on the picture, that can also lead to a so-called spaghetti architecture, because a lot of systems are connecting and talking to a lot of other systems. This is so more the one-to-one integration way, and there we see also more the kind of batch data movement. So because clients are requesting a batch of data and then they are processing the data. But this now shifts with MQTT to a new, not really new paradigm, but MQTT is fully based on publish-subscribe. It is really also nothing new, of course, but here we see in the center the centralized MQTT broker, where a lot of clients can connect to this broker and then publish data to topics. And the topic, a topic name in MQTT, is the key where data is stored. Yeah? And then on the other side, we have, of course, one or multiple subscribers on the other side, which can subscribe to the same topic. And when the publisher publishes data on the topic, then all the subscribed clients will get notified immediately. And so here we see also that we have here a one-to-many integration, yeah? And that also means that the systems are more loosely coupled. And here, because of this event-driven architecture, we see also this is more like real-time data streaming. And I have to note here, WinCC Open Architecture is doing it really in the same way. WinCC Open Architecture is fully event-driven, and we see here the same paradigm of publish and subscribe. So why is getting MQTT so famous? Yeah, first of all, it is really, really easy to use. Yeah? You can get started for free. You can download a broker, open source. Also, the big enterprise vendor broker are available on an open source basis, and you can install it very easy, start up, and then you can already publish and subscribe to data. No need to do a lot of configuration. And also, there are a lot of learning resources all around MQTT available on the internet. And Walker Reynolds, you see him here on the picture, he is the inventor and the driving force of the UNS, of the Unified Namespace concept. He says MQTT is currently the right technology for the UNS. Some basics about MQTT. How does it work? Yeah. First of all, it is data agnostic. And what does that mean? Well, that means that the broker is not aware of the content, what it is shipping from one client to another. So for the broker, it is just a chunk of bytes. Yeah. So he does not interpret the data. He does not know. He has no understanding of what he is delivering. On the one hand side, this is really good. Because of that, you can use a MQTT broker for a lot of different use cases. You can transmit text values, plain string values. You can transmit JSON. You can transmit pictures or even video streams. It doesn't matter for the broker. Yeah? But on the other hand side, the drawback is that, of course, the publisher and the subscriber must have the same understanding of the data. They must know what kind of data is published on a topic. Yeah? Because if they don't know what is on this topic, then they cannot read and interpret it and use it. Yeah? And so sender and receiver must speak, to say, the same language. In the middle, we see that the topics are hierarchically structured. So that means a topic name is divided by a slash or separated by a slash. And also in the levels, when you subscribe to a topic, you can use wildcards. Yeah? So in this example, here we have area, line, cell, OEE. So here you could say, I'm interested in the data of the area 1 and the production line number 2. And then I want to have all the data of all cells. And then I only want to have the OEE value. Yeah? So then you will subscribe to area 1, line 2, and then you give a plus sign. This is the wildcard in MQTT, and then OEE, and then you will get all the OEE values from all cells of only this specific line, what you are interested in. Flexibility, well, in MQTT, there's no need to define topics before you can use it. Yeah? A publisher can just start to publish on a new topic. Of course, only if he is allowed to publish on the topic. And this is also very important. Yeah? You have to take care. You have to use security not to allow every publisher to publish to any kind of a topic, because then a publisher can override value of other publishers, of course. Yeah? But anyhow, it is still very flexible, so you can, out of the box, just create these topics more or less on the fly. Well, MQTT, simple, powerful, as said, but still not really perfect. Yeah? There are also some limitations. And first of all, there's a limitation in querying and reading data. So in the standard MQTT, there is no way to read the namespace. So the broker cannot tell you what kind of topics are currently available. You cannot query that. Yeah? This is also because the topics can be created on the fly, and they only exist if there is a subscriber and a publisher. Yeah? And there's also no read functionality for topics. So you cannot ask, give me the latest and current value of this topic. This is not available in MQTT. The only thing what you can do is you can subscribe to the topic, but then you have to wait until the value changes, and then you will get notified, and then you will have the values. Of course, there are also other functionalities in MQTT, like retained messages. So if a publisher publishes a message on a topic with the retained flag, then this value is stored on the broker. And when a subscriber subscribes to the topic, then the first thing what he will get is this retained message. But the retained message must not necessarily be the latest value, yeah? Because the publisher can publish a retained message now and afterwards publish last and current values. There are also no function method calls, so there is no way to execute a function from one client and then get the result back, because everything is based on publish subscribe. There are workarounds for that. With that one, you can mimic, let's say, a function call, but it is still based on publish subscribe. And also MQTT version 5 has some additional functionality to make this a little bit easier, but even though it is still based on publish subscribe, and I would more or less call it a workaround. Yeah? Scalability and performance challenges. There are no bulk operations in MQTT available. What do I mean with that? So for example, if you have a machine with 100 metrics and you want to publish this 100 metrics on different topics, on different topic names, yeah, then you can do that only by publishing every single value in a loop, let's say, and then every single change of value is transmitted over the wire in a separate frame, let's say, on the wire. And that leads, of course, to a lot of round trips, and this can really have a big impact on scalability and performance. What you can do is to mitigate this, let's say, you can create a bulk message by your own, like a JSON object or a JSON array, and then put multiple metrics into this one payload, and then publish this on one topic. Then, of course, you will only have one round trip, but there's a big drawback with this, because when you are a subscriber, then you can only subscribe to this only one topic, and you will all the time get all the data of the machine, even if you are not interested in all of this data. Maybe you only want to display the current state of 100 machines. That means you need to subscribe to 100 topics, and you will get all the 100 metrics of all of the 100 machines. And this is, of course, totally inefficient. MQTT, long topic names. This can also be a problem. Topic names are always also transmitted in the message, and especially if we are using the UNS, then the topic names can get quite long, because we have this ISO 95 style naming conventions, for example, like enterprise, site, area, cell, and so on. So the topic names can really get long. And again, when you publish them values or a subscriber is subscribed to a topic, then with every single change of value, he will get the full topic name. Again, this is inefficient. With MQTT version 5, we are getting the feature of topic aliases. So then you can more or less substitute the name by number. But this has to be implemented by your client. So he has to take care which name will belong to which number. And also what I have seen in reality is that even if MQTT broker is MQTT version 5 compliant, then this does not necessarily mean that it really uses this at the subscriber side. Semantic model limitations. So there's only one hierarchically model what we have with the topic names, and there's no functionality. It is not possible to create other relationships. For example, in WinCC open architecture, we have our plant model, where you can build and create multiple different views to the same data. And this is not possible in MQTT. So coming now to technologies. So let's just roughly compare SCADA, MQTT, and Apache Kafka. Apache Kafka is a streaming platform. So it is on a very high level. It is a little bit similar to MQTT. It is based on publish-subscribe pattern. But behind the scenes, it works really different because Apache Kafka stores all the time the full stream of the changed value. So it's a streaming platform. Data store, in SCADA system, we typically, of course, we have the process image where we store and we know the last and current state of the tags and topics and data points. In SCADA, this is out of the box not the case. So if you don't use retained messages, then the broker only passes messages by without storing the last value. And as I have told you before, because of that, there's also no way to read the last well-known state of a topic. In Apache Kafka, it is the same as it is in MQTT. There's no way to get the latest current state of a topic because here we all the time have the stream of the data. Connections in SCADA systems, we typically see a limited number of connections. So we have a set of devices in which we are connected. We have our drivers, which are getting the data from the field and from the PLCs and so on. And there's a set of HMIs connected to it. This can increase a little bit, but it will not be that much compared to MQTT. In MQTT, you can have millions of connections. So again, this example about connected cars. You can connect 1 million cars driving all over the world to a central broker. And this broker then is, of course, clustered and can really scale out. In Apache Kafka, we also typically do not see that huge amount of connections that was compared to MQTT. So there we also have more the limited amount of connections, maybe in the area of thousands. So the packet size, yeah, in SCADA, especially in WinCC Open Architecture, it takes care for you to build the right packet size. So if you publish data, if you write, make a DP set on tags, or if values are coming from the PLC, then the system automatically creates packets to transmit this as one block, let's say, over the wire to make this as efficient as possible. Yeah? And you don't have to take care about it. In MQTT, yeah, I've already said that again also, a publish is always sent directly over the wire without building packages. And in Apache Kafka, there we see also packets. So this system also automatically, let's say the client library, creates packets. And Apache Kafka is well known that you can also publish maybe 10,000, 100,000 value changes per second on a single topic. Granularity, well, in SCADA, of course, we take care. We have a well-defined data structure. We define how a data point type looks like. We define what the data point elements are, what kind of data type it is. And of course, it is all the time possible to connect to a single data point element. Yeah, again, this example, I want to display the current state of 100 machines. That is easily possible. And even then, the SCADA system, WinCC Open Architecture, automatically takes care to create bulks and transmits this in an optimized way over the wire. In MQTT, yeah, we have this, in theory, we can do this fine granular connect on topics if you store every single sensor value or metric on a single topic. You can do that, but even then, every single change of value will be transmitted to the client, so it is not really very efficient, also not to build HMIs. Yeah? In Apache Kafka, yeah, there's no such fine granularity. In Apache Kafka, it is more typical. Let's say you have one machine and you put all of the data from this one machine on one topic. Yeah? So then you have a set of topics, and all of the data, all of the changing values will land on this single topic. HMI usability, yeah, of course, SCADA systems are made to build HMIs. It is perfect for that. MQTT, as I've already said and explained, yeah, because of this problems, let's say, with this, that there are no bulks or blocks are created and transmitted over the wire. It can be good, of course, if you have simple HMIs, then maybe it doesn't matter. But when you start to create full-blown HMIs with a lot of tags, then also this could lead to an impact, to have an impact on the network and traffic. And Apache Kafka, again, yeah, because you have, for example, all the data on one topic, it is not good for HMI. Yeah? Again, this example, I want only to display the current state of this one machine, then I have to subscribe to all my 100 machines to just get only the state out of every machine and then throw away all the other data, which is transmitted for no sense. Data historization. SCADA systems, well, WinCC Open Architecture as well. We have the option, of course, to historize the data in different databases, time series databases like InfluxDB or PostgreSQL or timescale database. In MQTT, this is not included, let's say, not included in the standard. Of course, the vendors of the big brokers, they also have add-ons to make this possible. Yeah, but again, it is not included in the standard. And then in Apache Kafka, of course, because it stores all the time the stream of the data, there we all the time have the history of the topics. And also with new versions of Apache Kafka, or at least in the Apache Kafka in the cloud with Confluent, there's also a new feature available where it automatically transforms also the stream of the data directly to Apache Iceberg tables. Payload. Very important, yeah, because MQTT is data agnostic. So because of that, we need somehow a standard which makes our life easier so that clients can talk to each other because they both speak the same language, the same standard. And one of those is Sparkplug B. So this is a standard hosted by the Eclipse Foundation. The data is stored in Google Protobuf, so it is binary encoded. So if you connect to an MQTT broker with a tool, then it is not human readable anymore, let's say. Everything is well defined. The payload is well defined. The data types are well defined. There are also the rules included, how devices have to behave or must behave. Sparkplug B primarily was made for dealing with devices. And we also see there that they decided to pack multiple, or the metrics are packed on one topic. So here we see that multiple metrics and changing values are stored all the time or transmitted all the time on one single topic, for one device, of course. Open source libraries, yeah, there are a lot of open source libraries available for the different and mostly used and main programming languages, so that makes your life easier to create a Sparkplug B compliant program. There is this Eclipse the Who project, which you can use. And also interesting is, or important, sometimes I'm getting the question, is my broker, can my broker handle Sparkplug B? Yeah, that's maybe the wrong question. So the only question you have to ask is the broker MQTT version 3.1.1 or higher compliant? Then you can use Sparkplug B with it. Because again, the broker does not care about the content. For the broker, this is just a binary bytes. So another payload format or standard is OPC OA PubSub. Of course, it is a standard by the OPC OA or OPC Foundation. It is similar to Sparkplug. It defines the messages. It defines rules, how participants have to behave. But with OPC OA PubSub, we see that it is not limited to MQTT. You may also use UDP or MQP, which is another broker technology or broker protocol, let's say. And yeah, it's not limited to MQTT. I'm not sure if I forgot to say, so Sparkplug B only works with MQTT because it leverages features from MQTT. In OPC OA PubSub, we also see that we have different message formats available. You can choose between JSON or binary. And also there, with JSON, you can choose between a very simple style of JSON or a JSON with a little bit more information, like that what you see on the right-hand side. This is good on the one-hand side. Again, yeah, you can choose and use the format which is the best for your use case. But on the other hand, again, it's similar to also problems that we see with OPC OA client and server, that the client and the server must implement the full rich set of features. And if it does not implement the full set of features, then potentially this could lead to that the client and the partners are not interoperable anymore. Yeah, well-defined standard, but still also very complex. And what we see as of now, we only see one reference implementation in C# and .NET. Yeah, good with OPC OA PubSub is that you can also leverage the power of OPC OA information models. But then again, you need an OPC OA server which provides the information model. So coming to the Unified Namespace. What is the Unified Namespace? Yeah, invented by Walker Reynolds. And first of all, it is not a standard. It is more structured and centralized data architecture, or let's say a concept. Yeah? And the core ideas are that it should represent the single source of truth of all the data, what you need to drive your business. And currently, Walker says MQTT is the right technology for that. So you have the central MQTT broker where all of the data lives in, and it should be semantically organized. For example, you can use the ISO 95 way to organize it. But again, also this is not a must. Yeah, if for your business or for you as a customer, it's better to have your own structure, then feel free to use your own structure. Yeah. Yeah. And it holds the current state of the business. Yeah. Again, MQTT does not out of the box store the history of data. So it is only the current state of the business. And also important to note here, so it does not only contain information from machines or PLCs, it should also contain information from MES system, production data and so on. And important here is also to say, it should give the ability that everyone can have easily access to that data of the business. Because to fulfill a certain task, currently or a lot of times, the biggest problem is that people do not have access to the needed data. And the UNS should also address this problem. And again, MQTT is one possible technology for it. And Walker Reynolds says currently it is the right technology. Coming back again to WinCC OA. So of course, OPC OA supports WinCC OA supports OPC OA client server for a long time, obviously, for sure. And we also have MQTT driver with support for different data formats. Also, it is available already for a long time. And with the driver, it is easy to get data from MQTT into WinCC OA, but it is also possible to push data from WinCC OA to a MQTT broker. And additionally, we have a MQTT publisher. And with that one, it gets really easy to, first of all, describe your, let's say, your unified namespace in WinCC Open Architecture with our plant model. And then you can choose a plant model and say, okay, I want to publish this plant model to a broker, maybe into an existing UNS, or maybe you create your own namespace there. Sparkplug B, currently we have a proof of concept. It is based or implemented in JavaScript. I have done this by my own. But the good point is product development is already in progress, so hopefully we will also see this really as a product soon. So, and now coming to WinCC OA in action. So let me first give a rough overview how the architecture will look like for our demo. So in the cloud, we have an MQTT broker. This is the monstermq.com. So this one I have made by my own. So it's my own self-made MQTT broker. Currently it is version 3.1.1 compliant. And I have hosted it in the cloud somewhere on a cloud instance. And on the left side, on the bottom, we see a photovoltaic plant, let's say. So it's my home, where I publish some data to this MQTT broker, just in a plain raw text style, let's say, but also additionally with a Sparkplug B data format, which we will then use in WinCC OA on the right-hand side, on the bottom, currently running in this case on a PC, but of course WinCC OA also runs on Linux and also on small devices like an IoT 2050 or even a Raspberry Pi. And there we will connect a little robot connected to Modbus or via Modbus TCP. So we will get the data directly and pull the data from the robot. And then we leverage the power of SCADA systems and WinCC Open Architecture to enrich and transform that data. And then after we did that, we publish the data to a broker, to the same broker, to the MonsterMQ. And then additionally, we will see a third-party application, let's say, a Sparkplug B application again, built in Unity 3D. And this one will then consume the data and visualize the robot in a 3D model. So, and now I will show to you how we can use the WinCC OA MQTT client to get data from the MQTT broker in the cloud into our WinCC OA system. And then I will show how we can use the MQTT publisher to publish enriched data enriched within the SCADA system in a UNS style with our plant model back to the broker. And then we will see a demo how auto-discovery can be done with WinCC Open Architecture. This is based on a program which was done by a colleague of mine. Let's see if this will also be at some point in time a product. So with that one, you can discover the broker, connect to a topic tree, and then it automatically fetches the topics, and it is building up a more or less the topic tree, and then you can automatically create out of that data points in WinCC OA. And then we will see a Sparkplug B integration, as already said, based on this proof of concept. And with that done, we will also see how then other clients, in that case Unity 3D, can consume this data, and in that example, then visualize a robot in a 3D visualization. So we see here now my broker in the cloud, where my home is publishing data to it, and also in a UNS way. We see here Siemens System 1, Austria, Mattersburg, so my hometown. And there we see some power meters, also some values from the photovoltaic system. And yeah, let's see now how we can get this into WinCC open architecture. So first of all, you need to start the MQTT client driver, and then you can already go into the configuration and configure the connections to one or also maybe more brokers. So you can also connect to more brokers and get data from multiple brokers and put them all together into WinCC open architecture, and then enrich the data or transform the data and then publish it back to another broker or consume or display or visualize it in WinCC open architecture. So here we have the MQTT client. So we have here the settings. Here we set where the broker lives, so how to get in contact with it. In that case, we have a broker version 3.1.1. In that case, I don't use any security, no username, no password. But of course, you should, of course, use here username and password at least. But you can also use certificates to connect in a more secure way to the broker. Yeah, and that's almost all. Once when you have done this, then you can already start to configure your data points. So let's see the example what I have prepared here. So my home, and I have here meter, the power meters, and the photovoltaic. And here, for example, we have the input, how much power my home is currently consuming from the power grid. And all what you have to do is here to add the address config, set the topic where the data comes from, the MQTT topic, set the driver number, and then you can choose here different transformation styles. In that case, I have just a plain string on the topic, so it is just only the value. But for the case, if you have a JSON, then you can also choose here between different JSON profiles. And you already see here, one is very simple with just a plain value. Another one is when also the timestamp is included in the JSON. Then we will take that timestamp, and the data point element will then also have the value, will have the timestamp of this received timestamp, of course. In that case, I want to subscribe, and that's already all. And then we already see the incoming data here. So the input, and we see this changing. Currently, I'm sending a lot of power to the grid. I have to mention here, my photovoltaic at home is already very old, so the maximum power is 4 kW peak. And what I also do here is, this one I'm getting from MQTT, and I also have added here an average value in WinCC OA. And this can easily be done with statistical functions, and you just set the source and you decide, in that case, I want to have the 3 minutes average. And that is already the way to show also how WinCC OA is here to get the raw data, enrich and transform the data so that then it can be used in a good way, for example, in an HMI. And the same I have done here with the photovoltaic values. I've made here a simple visualization, and then you see here. And also I have added an archive config. And with that done, we automatically historize the data, in that case in a PostgreSQL, so that we can also display here automatically also the history values. And here you see the current values. So, and now coming to the MQTT publisher. So with that done, first of all, it is again a manager what you have to start, the MQTT publisher. And all what you have to do then is go to the to the plant model. And with the plant model here, you can create one or more views to the existing data points in WinCC OA. And for example, for demonstration, I have already created here one. So now Czech Republic, Prague, system publisher. And then I have added here my meter and my photovoltaic data point. And this is more or less already all what you have to do. And then you just have to say and configure that this one should be published to MQTT. And when you have done this, then we will see here a new node, Czech, Prague, system publisher. And now we see here that data, and in that case, the raw data, the incoming data, and also the enriched data, let's say, so our average values, which we are now publishing back to the MQTT program. So this is very easy, and you see here the structure, and this structure can be defined by you, and this reflects then the unified namespace, or can reflect the unified namespace. So, MQTT auto discovery. So again, also for this, we have to start a manager. And let's open the panel, the screen for it. So, and here we see now we can already choose one of the already pre-configured MQTT connections. It will take the connection settings to here, and then I can add here a subscription topic, and here typically a wildcard is used at the end, So that means I want to discover everything what is below this UNS name, And let's start this. So I connect now. And now the system is listening on this topic with the wildcard. And we see here on the bottom, the already discovered topics. Of course, as I've said, in that case, the MQTT topics are not stored with a retained flag. And because of that, we have to wait until the topic is changing, and only when it is changing, we will get notified. So it is fully event-driven and reported by exception. So let's see, it seems to be the number is almost stable. And now we can display what we have discovered. And now we see this tree, this UNS tree in WinCC OA here. And now I can already say import, but before I do that, I will open the Para so that you can see that the tags are getting automatically created for you. So here we have 3 different types. Most of the things are float types. So, and now let's start the import. We discovered some more. Let's refresh. Okay. Now let us hide it. Move it a little bit. And then I say import. And now the system is creating all the tags for you automatically, and of course also with the needed address configuration to get the data in. And with that done, we are already getting the data into. Of course, we have to wait until the data changes. Let's see that in the screen. Let's start it. That was the wrong one, sorry. So now see here a discovered power meter. So these are small pluggable power meters at home. And this one is placed in my IT room where my computers are running. And you see that this room is currently consuming almost 60 watt. And currently, today, it has already consumed almost 1 kilowatt hour. Yeah, that is the very easy way to bring data and to discover data from a UNS MQTT broker and bring it to WinCC Open Architecture in a very fast and easy way. So let's now come to Sparkplug B integration. So we have here a tiny robot connected to WinCC OA via a Modbus interface. So the robot has a Modbus interface, and of course, WinCC OA as an IoT system is made to connect and collect values from different devices. So let's start here. Or did I already started it? Let's check. The Modbus driver is up and running. Yeah, okay. And so I can now turn on the robot and now move it to a destination so I can control here the 6 joints. So this is a robot with 6 degrees of freedom, and then I can execute. So send the command to move to that state, and when I press execute, then it will move accordingly. Let's turn it a little bit away from my nose. And yeah, so we are getting the data from the robot into WinCC Open Architecture as an IoT system, and also here, just to note, it is again important what we do here, because we are getting the raw values from the robot. It is called the NIRU robot. So here we are getting the original raw values into the system. And we see already here, this looks a little bit strange to me. So normally we should get here the milliradians of the joints, but this looks a little bit strange, and it turned out that this value has to be transformed to be really usable. And again, I do the same what I have done before. So I created another set of tags, data point elements, and I put here a data points function on it, where I can convert the values from the raw values to engineering values, let's say. And then let's take a look on it. Yeah, we see here now much more better and suitable values. And once we have that, we can then activate the MQTT part, the Sparkplug B part. So in that case, we are now a Sparkplug B edge node. Yeah, so we start the edge node manager, and the configuration of this is currently done. Yeah, I have told you before, it is a proof of concept. So the configuration is done with a JSON file where we configure host ID and all of the needed things what we need for Sparkplug B. And then here we can define what data points we want to publish as Sparkplug B to the broker. We set a group ID, edge node. Again, this is something what is important and needed for Sparkplug B. And somewhere on the bottom, we also have the robot. So we also publish these online values of the robot. So I started it. So let's see in the MQTT broker. And now we have to take a look at the Sparkplug B nodes here. Yeah, we see here the node data. So this is the structure of this topics and levels is defined by Sparkplug B. So it has to be in exactly that way. Here we see the group ID, and here now the node ID, and we have here now the robot. And doesn't really change. Let's move the robot a little bit. So now you see here the values. I mean, this is not really human readable anymore, yeah, because Sparkplug B is binary encoded with Google Protobuf. So, and once when we have done this, we can now also use another application, and in my case, I've used Unity 3D to create a 3D model of the robot. I mean, I have not created this by my own, so I've taken this open source from the vendor of this robot. And then I have used a MQTT asset. So in Unity 3D, they call libraries assets or asset. You can buy this in the asset store from Unity to have a very simple way to get connected to an MQTT broker. And then I have created also by myself a Sparkplug B implementation for Unity. And with that done, we will get the values into Unity, and then we connect the values to the joints so that we get a visual representation of the robot. So let's start this. So I have embedded this in a game. So it was my very first game I have developed. And I have to say, I'm not a game developer and I'm not good in creating good UIs, but this is just for demonstration. And now we see the robot here, and you see here the values of the joints. And when we start now again, the movements, let's put it here. So let's now control the robot again from WinCC Open Architecture. So I just start here a predefined sequence how the robot should move. Let's start it. Like this. Now you see the robot is moving in the same way as the real robot is moving. Yeah, because we are getting now the values, or we are pushing the values from WinCC OA with Sparkplug B to the cloud-hosted broker, and then Unity is getting the data again in Sparkplug B format, and now we see here both clients speak the same language, in that case Sparkplug B, and now they can easily talk to each other. And it is also some kind of an auto-discovery, so when you use this in Unity, all what you need to do is add here an host application. You set the host application ID, and then here the device, and that's all. And when you start the publisher and also start the client, then you automatically get what kind of metrics this device has available. First of all, because it is initially published when the device joins, and then you can easily reuse this in Unity. So, that's almost all what I have to show you. Only one more thing. So let's stop the robot here, because it is very noisy. So stop the loop. Okay. So that was the way when we publish. So again, we collect data from the robot, from the fields, from your machines, enrich them, transform them, and then we publish it back, in this case, in a Sparkplug B format to a central MQTT broker. But of course, we can also consume data, Sparkplug B data. So let me show also this as the last one. Here it is. So I have said at the beginning that my home also publishes data in MQTT format. So we see this. Where do we see this? We don't see this yet. Yeah, this is how Sparkplug B behaves. So when I start the primary host application, and the primary host application in that case is our WinCC OA. So only when I start this, then this gives a signal to MQTT, and the devices are listening on that signal. And when they get the signal, so the host application is alive, up and running, then they start to publish data, and not before. So let's start the host here. So, and now we should see here, yes, we already see it here, Vogler, and now we have seen here a birth message. The birth message contains what kind of data this device will publish. So it is the initial getting all of the metadata, and then when it is running, then we get the data here on this data topic. And here we see again data from my photovoltaic system, and yeah, and we now should also have this automatically as data points in WinCC OA. Let's see. So Sparkplug B host node. Yeah, here that ones were now created automatically, and you see here the same data what you see on in the MQTT Explorer. Yeah, sorry, I have shown you here already the extracted data in a JSON format. This is something what my self-made broker is automatically doing, but this is not normally the case in a normal broker. The really raw values you will see here, and again, this is binary encoded, so you cannot read it here. But when we are getting that Sparkplug B data into WinCC Open Architecture, then of course we also decode it, and we have this JSON data here on the tag. So forward. Yeah, here we see it. Well, that was all what I wanted to show to you. I hope it demonstrated very well how WinCC OA integrates in an easy way to MQTT and also to Sparkplug B. We can bring data from MQTT in a very easy and fast way to WinCC Open Architecture, enrich the data, transform the data, use the data, visualize the data, historize the data, and also potentially bring it back again, enriched to the MQTT broker. So, yeah, thank you very much for watching. And don't forget to subscribe and follow us on LinkedIn and also on YouTube.